Welcome everyone to this webinar about color process control. I'm happy to have a special guest here today, the one and only Steve Upton from Chromix. Hi, Steve. Thank you for joining us today, and let's have a good time. Steve, we're very curious what you have for us. So I will start with a brief introduction and then hand over to Steve later. So without further ado, let's start this session. So today we talk about color process control in industrial digital printing. I'm your host and speaker, Viktor Lazzeri. I'm a business development manager from Barbieri, and as said today here with our guest speaker, Steve Upton from Chromix. So let's get this started. So what our agenda today, we talk about color process control in industrial digital printing. First, we tackle the challenges in digital printing. Then we answer the question, why do colors variate? We speak about the role of measurement technology in process control. Then brief introduction to color process control in industrial digital printing. And then I hand over to Steve Upton, who gives us an in-depth about color process control. And then at the end, we have time for a Q&A session. So industrial digital printing offers a variety of applications. You have interior or textile printing, there's ceramic, glass printing, automotive sector has digital printing, decor, to name a few, and of course there are many more. So industrial digital printing offers a variety of applications, printable materials, and printable colors, which leads to a major challenge: accurate color results throughout different applications. The components involved in color reproduction, so it all starts with a digital file, image, or a pattern, RIP software using ICC profiles, digital printers, which are fed with different materials, different inks, and additional pre or post treatments. And of course, also measurement technology, spectrophotometers, who speak to the software by measuring the output of the digital printers. So, to sum this up, different applications, printer material ink, require different production workflow and different pre and post treatments. This leads to a different color gamut or the amount of printable colors. Let's look at an example, different gamut sizes in digital printing. Let's look at textile printing. We have a variety of applications there as well. To pick two, we see that one application has a different gamut than another application. Of course, this does not mean that one application is better than the other. It's just different. And to have this to receive these gamut sizes, to receive this color gamut, we need measurement technology, a spectrophotometer. So, in order to have accurate color measurements, they are fundamental to obtain the gamut and then to implement color process control. This leads to a question, how we obtain accurate measurements. As we know, there are challenges in digital printing. So what are the challenges to obtain accurate measurement results on a variety of industrial materials? So I have two examples here. See textile material on the left side and ceramic on the right side. So first thing that catches our eye is the structure of the surface. You have woven fibers on the textile material, very uneven surface, and we have a very rough surface on this ceramic print, which is even, by the way, a little bit dirty, as you see here. Then there are different ink types. there is a different material handling for different materials. And there is, for example, challenges like backlit printing, backlit material like glass, and of course, many, many more other challenges. So how can we handle all of these challenges? And I picked out a few to talk about more specifically. So how do we handle different structures on materials? The measurement aperture size defines how much of a certain patch is seen and measured. As you see here in this picture, a small measurement aperture will capture some light information and some light information gets lost. With a larger aperture, of course, more light information is captured and less light information gets lost. So the general rule is the bigger the aperture, the more accurate a measurement will be. The Spectral FPQB can adapt the measurement aperture automatically to 2, 6, and 8 millimeters. Let's look at an example, a low resolution print. We have here a small aperture which captures some green, some blue, and we have on the right side a large aperture which captures a lot more information, even captures this little red spot, which just means it's more accurate. Same thing to structured materials. Small aperture catches almost nothing of the material, just the white background, and the large aperture on the right side catches a lot of the material, a lot of these red fibers of the surface. So the best results in structure is a large 8 millimeter aperture to be used with the Spectral. Let's have a brief look at this video to explain a bit better what I just explained.
What's the real challenge when it comes to color measurement on different digitally printed materials? It is important to avoid wrong measurements caused by a minute measuring aperture. Materials with even surface and high-resolution prints can be measured with a small aperture so that many patches can fit on one single page for easier handling. Structured materials and surfaces require a larger aperture and larger patches to reach the highest level of accuracy. With our professional R&D department, we have been able to look closely at the obstacles and find the best solution. The Spectral LFP QB with its variable 2 to 8 millimeter aperture. By using a motor-driven optical zoom, the aperture size can be adapted automatically. This single instrument can be used to accurately measure a variety of different digitally printed materials to get the most accurate results every day.
So the next challenge I want to talk about is how to handle the mounting of industrial material. Some materials are heavy and thick and therefore very difficult to prepare for color measurement. So to solve this, we need different sample holders. You see here on the left side a sample holder for thick, transparent material. You see here a sheet of glass which is taped to a special sample holder, which then can be mounted to the Barbieri measurement device. There's also a sample holder for thick reflective material. You see here the video on the right side. The sample holder is prepared. And then, for example, we have a heavy piece of ceramic, which is fixed to the sample holder, placed in the right position, put with the magnet so that it doesn't move, and then it can be mounted easily to the Spectral LFP-QB. So correct sample holder for each type of material guarantees accurate material handling and color measurement. And the Spectral LFP-QB can be equipped with sample holders for heavy, thick, transparent, reflective, and many, many more different materials. So make sure to always use the right sample holder for your material. So we learned that accurate color measurement, material handling, how to handle the charts is fundamental so that we have accurate spectral data. Now we come to the topic of this webinar, how to perform then color process control in industrial digital printing. Start with the definition. Process control in digital printing is a series of actions which ensure output meets expectation by managing variables which can impact production. The main objective is to ensure accurate and consistent color reproduction by creating a tailored solution for each printer material and ink combination. A very long definition, but for us important, first and foremost, we want to know if my print is either not passed out of tolerances or passed. This leads to 3 questions. How do we check if output meets expectation? How do we check if colors are printed accurate? And how do we check if colors are printed consistent? Solution, or the answer is to print and measure control strips. We have here 2 examples from the Barbieri DOC solution, a CMYK and a RGB control strip. So what are the different steps to perform in order to obtain color process control? It all starts with the calibration of the printer or the linearization. Then we must profile the printer, set it up correctly, and then we can go to the step of the verification. Means we verify if our printer prints against the reference printing condition. You see a few examples here, ISO 15339, Rockwool-Foga textile RGB, or even your house standard. And this to know if I printed the color accurately. After I check that, I'm sure, okay, I hit my colors accurately, I can start my production. And now the 5th step is to validate my printing. And I do that by continuously print and measure control strips. And this gives me information about how consistent my printer hits the colors. So, what is a control strip? A control strip is a set of patches including solid, secondary, and grayscale colors. You see here a few examples. Let's start with the Barbieri DOC control strip CMYK. There are other control strips out there in the industry. There's, for example, from Foga, a textile RGB media wedge, and there's from Idealliance, a large aperture device control strip. So what information comes with a control strip? Let's break down the Barbieri DOC control strip. So there's many patches, 48 to be exact, on this control strip, and there are some different categories. So we have the primary colors, primary mid and shadow tones, have the secondary colors, secondary mid and shadow tones. I have my chromatic grays, I have the white point. So I have a lot of information on these control strips. And this, of course, is needed to do the final step of evaluating the results of my measurements. So before we go to the evaluation, let's just quickly see how the Barbieri LFPQB measures this control strip. So you see here, automated solution to run over this control strip fast and accurate to obtain the spectral data needed for evaluation. So that's it. As you've seen, automated solution, all goes quick and easy. After we did that, we have the spectral data. And with that, for example, you see here how an evaluation can look like. Here you see the Barbieri DOC report. So you see all the, on the bottom side, you see all the values from the single patches, and you see the DOC results, more summary of all of it. You have other information like what printer, what media, the time of the measurement, and so on. But of course, the most important part for us is the actual results, the evaluation. So let's zoom in there and see at the doc results what information we get from this report. We have information about the uniformity, we have information about the color accuracy. We have also information about the media, material, which is very important. And Most important information here, of course, I want to know, did I pass? Is my print fine? Did I hit it? Can I continue with my production? So that's an example of an evaluation of such a control strip. So now we had an introduction to the topic, and now I'm happy to hand over to my colleague, Steve. Very curious what he has now to tell us. So please, Steve, go ahead and tell us more about color process control.
Okay, just in the process of sharing my screen here. Okay, thanks, Viktor. I'll just expand a little bit on some of the choices that can be made when determining how to evaluate things in a process control situation. This is a little bit of a review, I guess you could say, that it's about taking measurements and effectively gathering sample data as much as you can. And the Barbieri instruments are great. We love them for their flexibility and their ability to measure strange materials, frankly, and weirder materials, and that makes it a challenge for the instruments. Instruments that are only made to measure on flat paper don't necessarily do a good job of handling the bumpy surfaces and that sort of thing. But there are some important steps here, clearly. When the measurements are taken, we gather a whole bunch of information, but the purpose of that really is to calculate color differences. Delta E is a very important part of that, as you can imagine. And the ranges of delta E are very important. The idea behind it overall is that less than 1 delta E is unnoticeable. Greater than 1 could be a problem. Greater than 5 tends to be a problem, and greater than that, even more so. Determining the pass-fail can be a complex process. And Viktor went into a fair amount of detail about how that can happen, but I want to talk a little bit about the myth of the single metric that we've seen in the industry, with some customers getting confused with this and saying, I just want one number to tell me, everything I need to know. And that doesn't work very well. That really does assume that you have a single type on top of that everything in the print process, the equipment, the paper, operators, the environment, and everything else is only expected to have a single type of problem. And that's just not practical. So a single go, no-go, pass-fail grade is definitely possible. And most process control systems will offer that, including ours. But it's not going to be based on a single metric, and you probably don't want it to be. The idea is gray balance is important. We get involved in G7 and near neutral calibration a lot in the industry, and that helps in a big way make print stable. So you'd think that matters the most, but it matters the most until you realize the customer's brand colors are more important, or flesh tones. And there really are a lot of challenges, involved in balancing the needs. So we've broken it down here into 2 different groups. The things you want to monitor for customer satisfaction, like the smoothness of the imagery. That's the kind of the calibration stuff I'm talking about, and that also includes gray balance. The color of brand colors, saturation, and dynamic range of the images, that sort of thing. There are a lot of these parts that are, generally about the viewing and just the pleasing nature of the images. Then there are the items that you should monitor that have to do with what you can control. From an engineering perspective, they say you should monitor directly the things you can control. And so that's the things like in the digital world, calibration and profiling, the ink and media that you're using, whether or not they get contaminated, whether or not the correct media was used, because that gets, incorrectly chosen at different points. Different consumables that can age within your printing system, your environment, and the workflow. The workflow is really very important because there, as Viktor mentioned, the digital front end and the RIP side of things it needs to be configured at the beginning, of course, but that can be changed unintentionally. The wrong calibration selected, the wrong print queue selected, that sort of thing. And if you are sampling in the right way, that you can detect when that kind of problem emerges. So ongoing color verification requires this measurements of color patches, regularly. And as Viktor mentioned, they should be distributed around through the gamut. And they should include the basic things like ink channel values, like not just cyan, but different tints of cyan, that kind of idea, and the media color. That goes a long way toward verifying that the correct medium was chosen. How does our system help? Well, we give the kind of rapid go, no-go color approval. Our system is called Maxwell, and we utilize the Barbieri instruments and others to help the operator quickly take measurements and give the feedback directly to the operator, so that they can quickly see in a visual way the pass-fail nature of things, as well as any possibility problems that might be emerging as a printing system shifts, that kind of idea. The final color quality is essential here. Making sure that, like, for instance, G7 metrics are used to get, good calibration, good gray balance, that sort of thing. And a variety of these different metrics to make sure that things are tested across the needs of the things I mentioned before, whether it's the different types of problems the customer might recognize, or also indications of the problems that of the things in the system that you can change or that could be accidentally changed. An effective system also gives enough information to shorten the troubleshooting of the problem. When problems occur, it's nice to have a little more information from additional patches at times, or some additional analysis that helps the operators or press techs or other support personnel to look into the problems in a little more depth and see what kind of things might be going on, whether there are ink contaminations or, as I mentioned, media problems, measurement problems. It's nice to have a system that actually monitors the measurement equipment itself and allows you to do verification of that. And then allows you to share that information with the support teams, whether or not they're located on the same premise. And those can be internal support people or your vendors or consultants or whoever you choose to help with that support side of things. The idea is to get you back into production quickly so that the problem can be diagnosed, fixed, and then production can can proceed as quickly as possible. So trend lines are also very helpful to see when problems are starting to emerge. This kind of thing can definitely happen, especially when you have, like, for instance, ink contamination or nozzle clogging, that kind of thing. Those accumulate over time. So they might show up a little bit in an earlier measurement, but as they go forward and measure regularly, you can start to see trends emerge. Instrument problems can also show up in this way when the instruments get dirty and that sort of thing. The Barbieris have some nice features to help and keep the optics clear in industrial and situations, where with textiles and all the fiber problems and that sort of thing, which is nice. But you can get these kinds of problems emerging, and it's nice to be able to keep an eye on them. Another place this can occur is for heating, ventilation, HVAC kind of problems, and they can show up over time. It's also very nice to have comparisons between the current behavior of a press and the past behavior, from a diagnostic perspective, you can get a feeling, because sometimes an operator won't necessarily, sorry, a support person won't necessarily be that familiar with just how that particular output device works on the media and that sort of thing. There can be more variation in some systems than others, and also from the measurement perspective. So it's nice to have comparative data to look at and compare with the past behavior. You can look at it and say, well, it looks a little weird right now, but it seems to always print that way, for instance. Or you can also do press-to-press comparisons, which can be very handy to allow you to see how different your presses are. If you have multiple output devices that are supposed to be printing in a similar manner, it's nice to be able to do a quick comparison of that, get a feeling for whether or not that's occurring. That can help you move jobs back and forth or split jobs between presses. It's nice to have multiple output devices, but it's essential that they operate in a very similar manner so that you can split a job across them and it doesn't look any different from the customer perspective. Ultimately, the idea behind a system like this is to give you confidence. I love this picture of this little fellow. He just looks like he owns whatever world he's in. And it's nice to be able to gain confidence from a system like this. And we've done some analysis of this and determined just how a process control system can aid in giving confidence all the way across a printing organization. Whether you're just receiving delivery of new equipment, you're doing print product design and development, you're laying out some new print thing that you want to do, and in this digital world there's some great opportunities here. It's nice to take measurements at that time and have confidence in that process. But then, of course, when it goes in production, you can take measurements at that point and confirm, because production can often involve different setups, maybe different media, different workflows, and you want to make sure that when things go into production, that they are reflecting what was developed by your print product group. Of course, sales loves to be able to see that a system is stable, and they also like to be able to know when they try to win new customers that they can say things with confidence, like, for instance, that they can print to certain standards, for instance, or that their proofing system matches the production system well, these sorts of things. It's nice to have that confidence from the sales point of view. Customers love to have access to this kind of information if you want to allow it. And there are ways to do that in a limited manner that doesn't necessarily put at risk. In fact, it doesn't have to put you at great risk, but it can allow the customer into the fold and increase the relationship you have with the customer. And they like that. When it comes to managing press rooms, as I mentioned, being able to pair presses to each other, facility management can benefit from monitoring environmental information. We monitor outdoor environmental and weather information in addition to facility temperature and humidity and that sort of thing, if customers want. And then if problems arise, and see if it's related to a problem that has to do with keeping your humidity stable or your temperature stable. We have customers who print in environments that can be quite different from winter to summer, for instance. And they like to be able to see if the systems are being held stable, and then also if that affects cost, so they can overlay and do that sort of thing. Again, tech support, press techs and operators can benefit from this. In fact, we've noticed operators love this sort of thing. At first, there can be concern from operators and from management that the operators aren't going to like this. They're going to feel like all this monitoring is bad, but it turns out they do like it. Most in fact, they do like it because they can what the direct influence that their actions have, and they can also see when they're doing things properly, and they can actively. The problems that are occurring aren't their fault. So this reaches all the way up into the company management, but knowing how to make changes to the AD systems, for instance, as well as our team, knowing things are being measured in the standard and that the instruments agree with each other and that sort of thing. Well, there are a lot of benefits across all of those things. I've kind of zipped through these slides fairly quickly, but I just wanted to give an overview for how, basically how the metrics that you choose can make a difference, and that it's wise to choose a variety of metrics to keep an eye on your color monitoring system and give you good feedback both from your customer's perspective and from your own. So I will hand things back to Viktor, and we can go from here.
All right, thank you so much, Steve, for this very interesting insight. So I think this brings us to the end. So we are happy now to take your questions, and so I will share my screen one more time, and thank you once again, Steve, for this summary. And well, what we discussed today is that color can vary in different digital printers. We saw that different materials cause challenges for measurement devices, therefore dedicated color measurement device ensures accurate spectral data. And we learned a lot about color process control, and that it tells us about how accurate and consistent colors are printed on our printers. And now, once again, thank you all for joining today, and we are happy now to answer all of your questions in Zoom. So in your application, you should have a Q&A box. So feel free to ask your questions, write them in, and Steve and I will happily answer all of your questions.